Okay, so we have a cluster. It's green, which is awesome. It's telling me that I have 3 nodes and a certain pool of resources. That's our bucket for Lego blocks. My partner always tells me they're not Legos, they're Lego blocks. Okay, so if we take a look at it, it's going to give us a little bit more info. So here at the bottom, this is one of the interesting things, is that they show you the instance groups. Instance groups are like auto-scaling groups if you're familiar with the AWS world. They have a launch config, nodes come up, they get provisioned, so that's why you can throw them away. In this case, we have 3 of them because we have 3 different availability zones available. So connect to cluster. Let's click on that. So in this demo, I'm going to use the Cloud Console because it's easy and it already has all the tools that we need to communicate with Kubernetes. You can do this in your terminal, but you're going to have to install gcloud and do a bunch of configuration. So that's on you if you want to do that. So please do if you want, but otherwise just go ahead and follow along with the Cloud Console. So I'm going to go ahead and copy and paste this line. It's essentially getting my credentials from Google to connect to my cluster. So I'm going to copy that. I actually have another tab open with Cloud Console because space is kind of an issue on the screen here. So Cloud Console will essentially drop me into a shell. Hopefully we're all familiar with this. And this is a workspace for me to communicate with my Kubernetes cluster. It's going to have everything installed that I need. It has kubectl, which I'll talk about in a second. And it's going to allow me to get everything I need. One of the things that I love about Kubernetes as a ops person, as a developer, is that you can interact with it completely by command line. You don't have to do GUI if you don't want. We're doing a bunch of GUI here to stand up a cluster, but you could automate all this. You could script all this. And kubectl can be scripted. ReactiveOps actually has a package called Rocket Scripts, which is open source on our GitHub page. And it is essentially a suite of bash scripts that will wrap kubectl in a lot of nice little packages so that you can do things like deploy your applications, deploy services, etc. So check that out if you're interested. Otherwise, you can write your own package. Kubectl is all just command line stuff. So I copied that config line. I'm going to paste it here. I'm sorry, what? Oh, I'm sorry. I didn't show you that. Thank you. He said, how do you get to the Cloud Console? So let me go back to this page. This little icon here that looks like a shell, if you click on it, it will pop up down here. And then you can rearrange it to your heart's content. So, it looks like you can only have one instance of it at a time. So I have that get credentials line. I'm going to go ahead and hit that. And what it's going to do is it's going to go ahead and pull that kube config that we talked about. Because this is a throwaway cluster on a throwaway account, I think that I can potentially show you what that looks like without, can I do a tilde? Yeah. Yeah, OK. So the classic location for the kube config is in your home directory under the .kube hidden folder config. You can put this wherever you want and then set it as an environment variable if you'd like. But this is the classic location. And I should probably look at it in something other than cat so that we can scroll through it. So if you take a look, it looks like a bunch of gobbledygook. It's really just certificates. So at the top, it's going to list all of the clusters that I have access to. And then if we scroll down a little bit further, we see a section called contexts, which I'll talk about in a second. And then if we go a little bit further, it's going to show us a list of users. So those are the 3 things that you want to keep in mind with a kube config: cluster, users, and contexts, which have to do with namespaces. So I have this kube config. This file is going to allow me to talk to the cluster. So the first command that I want to run to make sure my cluster is up and running is kubectl get nodes. What this should do is go out to the API server and say, hey, give me a list of nodes. And if we take a look at that, I have my 3 nodes, and they are of a certain version. There are all kinds of fancy things that you can do on the command line, like this is my favorite one, wide, which gives you more information.
Would this only work if you have kubectl proxy running locally?
Nope. This should work on Cloud Config or Cloud Console. Like I said, if you do it in your terminal, there's a couple more hoops that you have to jump through. You have to do an auth, and you have to have the SDK installed, I believe, or at least, yeah. Okay, so we have our list of nodes. That's cool. You'll see there's a lot of patterns in kubectl. There's get, and there's describe, and there's delete. Those are the three that I use the most. And you can do that on almost any resource. So if I say kubectl describe node, which is the type, and then I pull one of these names, I can take a look at details about the node, which is really neat. So I can say, let's see, at the top there's labels. Kubernetes adds a bunch of labels by default. So you can see here that, oh, it's got FluentD installed. It's of N1 standard 1 type. It's in US East 1B, which is cool. And then there's some more useful things. There's conditions, which will tell you kind of what's happening with the node, if it has enough disk space, if it has enough memory, if the kubelet is ready. And then down here at the bottom is some of my favorite stuff. So you can see what all the pods that are running on that node. This will change as pods are scheduled to that node. And then at the bottom is like your first stop for debugging. These are events, and it will tell you what's happening with that node. You can do events for nodes, you can do events for pods, and it'll basically show you the life cycle of whatever resource you're looking at. So in this case, my node was starting, and then it has plenty of disk space and memory, and then it was ready. And those are in reverse chronological order. If you do kubectl get events, which will give you the events from the entire cluster, it's not always in chronological order. And so you'll see up here there's like 8 minutes and then 10 minutes and that. But you can filter that to sort it however you like. But these events are kind of useful in debugging your cluster if that's something that you're interested in doing. So where were we? We've got get nodes. We've got our nodes. Cool. So now we can potentially start doing stuff. Now, one of the things that I recommend to all of my customers and to you guys is that you use what is called a namespace. A namespace in Kubernetes is really cool. It's another way to segment out your workflow or your workload. So let's say that you are a developer. We have a customer that has a ton of developers, and they have feature branches, right? And they all are working on their feature branches all at the same time, and they all want to see it. And so what we have is a setup where every time they create a feature branch, it creates a new namespace. All of their work goes into that namespace, which allows them to run any number of applications. And all of those applications can talk to each other. Unless you specify otherwise, applications within a namespace can talk to each other through DNS just by calling out their names. And you can jump namespaces to share DNS, but you just have to jump through a couple more hoops. So namespaces by default are a little bit nice of a separation. You could potentially draw more boundaries on a namespace, security context, things like that. But I think they're really useful as a logical separation. So what we're going to do is create a namespace for this workshop and create. So it's kubectl. What do you want to do? What type of thing do you want to do it on? What thing do you want to do it on? So kubectl create namespace. You could probably type it out, but I always do ns. And then I'm going to give it a name, so I'll say workshop. So this is going to create me a namespace, and you can do kubectl delete namespace if you wanted to get rid of it. If I say kubectl get namespace, it should list them all for me. There's a couple default ones, as you see here. Default, kube public, kube system, and there's my workshop one. Now the cool thing is that if you have like that situation I talked about before where all the developers are working in their own namespaces and say you need to start cleaning them up because there's branches that got old, if you delete a namespace, it deletes all the resources in it. So it's not like you have to do everything by hand. You can just wholesale delete a whole namespace, which is kind of nice. So now we need to be able to use that namespace. One of the ways you can do that is if you do kubectl with a -n, you can specify what namespace you want to work in, which is fine. It gets a little tedious if you're doing it for every command, right? And it also allows a lot of mistakes. So you could potentially deploy to the wrong namespace if you're not using this n flag, which, okay. Just kind of try to work with that. The thing that you could do if you want to work within one namespace for all eternity is create a context. We saw that in our kubeconfig. The default context in your kubeconfig is the cluster, which is not entirely useful. However, if you have multiple clusters, maybe it is. So what we're going to do is create a context. It's just going to make it a little bit easier for us. So we need to do kubectl config set context. I'm going to give it a name, workshop. And then I have to give it those three things we talked about: a cluster, a namespace, and a user. Before I do this, I need to check out what I already have. Get contexts. It's going to show me what I have. And I'm going to, oh, I already have one that's from an old cluster. That's nice. This is the cluster I have now. So I am going to create a namespace, or create a context rather. Set context, workshop, cluster, user. So in this case, remember we talked about kubeconfigs and you could create specific client certificates. You could name them however you wanted to. The default one is the entire cluster. And so in this case, the entire cluster is the user. And the namespace should be workshop. OK, yes?
Yeah. Move the browser to up the screen. I can't see it.
Oh, because other people? Sure.
Where did you get this user?
Where did I get the user? So that's kind of what I just mentioned, is that in the kubeconfig, if you're using the default one, which is the entire cluster authorization, so everybody has the same authorization, then the user is just the cluster name. Does that make sense? Okay. So it set me a context, and now I should be able to config use context workshop. Okay, so now I am working in the namespace workshop on that cluster. And I don't have to worry about that namespace flag, which is cool. So I can say kubectl get pods just as a test to see if there's anything there. Oh, of course, I used the wrong cluster. This is what I get for practicing. Central. So I'm going to rerun that command. I can't do Control K. Sorry, 1 second. Hopefully everybody else is getting a context set. OK, let's try that again. Maybe. Is everybody else getting a context OK? While I wait for this to come back. It is. It's not behaving right now. US, oh, you're right, East. Thank you. So let this be a lesson to you. This is something you should never do. I created a new cluster in the same project. And so now I have to deal with having multiple clusters, right? So this is kind of one of the arguments for having projects is keep your stuff separate. So that is my takeaway from this. So the thing that I see people use context for a lot with with clusters is, say you have an environment like development or staging or production, and you want all of your developers to be able to use those as if they're in a specific environment. You can create context for each of those environments that point to a specific namespace, and then they can use that as if they are in an environment. So thank you for your help. Now I had a get pods, and I have no resources, which is exactly what I wanted. So now, how do we get resources? So if we think back to those primitives, what do we need? We needed our app, containers, right? And we need, those are the ingredients, and we need a deployment, right? That's our recipe. So one of my colleagues who did the San Francisco workshop put together this very nice repo, which has a dummy app in it. So you guys can go to this URL, github.com/reactiveops/Kate's-workshop, and you should see the repo, which is two things. It is a web app, which is very basic. If you look inside the code, it's Ruby. It's a little Sinatra app that basically allows us to get and set key value pairs in Redis. So it's just a little dummy thing. And then, so that means, by the nature of it being an app that writes to Redis, that means we need our app and we need Redis. So that's cool. So how are we going to design that? How are we going to architect it? Well, I need a web app pod, and I need a Redis pod. And in this case, so in most cases, you're going to be running Redis as a master minion setup. And so this could be potentially interesting in that we could set up a deployment for the web app, and we can have a deployment for Redis. Maybe the deployment should have masters and nodes separate in Redis. So let's take a look at what that looks like. At the root of the repository, you'll see Redis. Let's take a look in there. So we have now some resources. Kubernetes defines resources in YAML, which I'm a huge fan of. You can tell me later how much you love JSON. I love YAML because it's readable, and I don't have to do quotes and curly brackets and all that nonsense. And so I think it's great. And so what you need to do, if you want to write Kubernetes resources, is define a resource in YAML. Now, the documentation is great. It goes to extensive detail about all of the features available. There are a ton. And so what you're going to see here, probably just a few. So this is a deployment. So you saw a little bit of this earlier, and it is my recipe for doing things, right? So I have the API version of the resource that I'm using, the kind, which is deployment in this case. I'm going to give it a name. Kubernetes allows you to have a lot of power based on names and labels. So you could potentially choose what pods are running behind a service by name or label. So you could potentially put a lot of metadata into these. So in this case, we have some labels set. The app is called Redis. In this case, it's going to be a master, and it's the backend here. Those are all just kind of important in this case. And so now we have the spec. The spec is the real meat of the recipe. It's going to tell us how that pod is designed. So you have a containers list. It's an array, you can tell by the dash there. This is the first entry. And in this case, we're running one container in this pod, which is good. I think it's our practice to do as much as we can one container per pod. You could potentially have a really good use case for multi-container pods. I would love to hear it. And so now we're just going to define that one container in this pod. We're going to call this master. This is the Docker image that it's going to use. It's just the Redis from the Google registry. And then resources, because you can define the size of this container, the size of this Lego block, you could potentially define the resources that it's allowed. So we have this bucket of resources, and maybe you want to limit what this container can use from it. So in this case, there's two types of resources. One is called requests, and one is called limits. In this case, I didn't define any limits. The requests are the resources that a container, a pod, is going to ask for when it is scheduled. So you say you have a node, and it has 200 megabytes available. of RAM, and it has 400 CPU, 400 M. Does M make sense to everyone? M is a millicore. So it's a 1,000th of a CPU core. So you can schedule really, really tiny pods, which is awesome. So request is what a container is going to ask for when it gets scheduled. A container, if it fits, it sits, okay? And the second definition, which I don't have here, is a limit. The limit is what it sounds like, how big that container can grow, okay? There's a lot of detail in the Kubernetes docs about setting the resources, the requests and limits. Based on how you set them, it can mean something for scheduling. So if you have the requests and limits set to the same values, it could potentially mean that your quality of service is different than if you have requests different limits and things like that. Please look at that later or ask me about it later. In this case, it's going to ask for 100 M and 100 megabytes of RAM, and it can grow to however big it wants. If you set a limit and it grows to that limit, an ohm killer would kill it. A lot of customers that I have will not know these requests and limits very well until they start running in production. And that can become a problem because they'll hit their limits, which they never knew. They'll say, I never knew my app could use that much RAM. Well, it's true. And it uses 4 gigs of RAM, and then the ohm killer will kill it. The nice thing is that Kubernetes will spin up a new pod in its place, so it'll start all over again. But if you have a memory leak, you have a problem. If you don't set it, as far as I know, it has as much resources as it wants. And then the last part of this is setting a port. Just as you do with Docker Native, you set a port that is going to be accessible into your container. So that's a deployment. It's a really simple one. There's a lot more that you can do with it, but that is going to get us a Redis master pod. Okay. If we go back to the Redis folder, there's a slave deployment. I don't like to call them slaves. I'm going to call it a minion. So here's what that looks like. The only difference is essentially some metadata, and the image is different. So this is a minion image, and it has an environment variable that's set. In this case, the environment variable is static. It's just set to get hosts from DNS. So I do want to point this out really quickly, is that this environment section is where you really can leverage all the power of containers. Because you can change the config at runtime, because every time you start a container, it will pull in these environment variables, you can change them whenever you'd like. And I really love when customers use environment variables instead of config files, if at all possible. I know it's hard, but it really does get you a lot of flexibility and the ability to tinker with things without deploying new images. Okay.
It recognizes that it's an environmental variable just because it just matches what's in the environment, or not?
If your application, you mean? Okay. So he asked, does it recognize that it's an environment variable just because it's defined that way? Well, you have to write your application to leverage environment variables, if that's what you're asking. So you can set an environment variable here. It's going to exist in your container, but if your app doesn't use it, then you need to change that, right? Your app's not going to know magically, sadly. Okay, so this is our minion deployment.
Question on the environment variables. What about like secrets and secret management?
Secret management is a huge can of worms, right? So not evidenced here, but there are 2 types of data that you can feed into your containers. Config maps, okay? A config map can be a lot of things. It's usually key value pairs of configuration values. So just like this environment variable is set, you could potentially create a config map that defines, so rather than having a static value here, you could say, get that value from a config map. Config map is essentially just a resource that has key value pairs, right? So I can store this somewhere else. The nice thing about that is that this is a deployment. These values could be different in different namespaces or different environments, right? And so you could have potentially, if you feed in a value instead of use a static one, then depending on what namespace is in, that might be different, right? And you can control that by config maps. Sadly, I don't have an example for you, but you can certainly get with me after, and I can show you. The second type of data that you can read in, well, actually, let me go back. Config maps can also be file mounts. I talked to somebody about this before the workshop. If you do have a config file, which is fine, you can mount it, just like you would in Docker, right? So you can essentially mount a file. What's really cool about Kubernetes is that you write a config map just as you would with a key value pair, and you put the content of the file in there. And that content of the file will be mounted as a file object in your container. And you can put it wherever you'd like. It used to be that you had to mount an entire folder, but now you can basically project a file to anywhere in your container. So you could overlay your config at runtime, which is cool. We have some customers really wanting to do that. And secrets. So secrets is the second type. Secrets, like I said, is a can of worms, right? It's super important. So Kubernetes has an object called secrets. It stores the values of these secrets in etcd. So based on how you configure etcd, those secrets could be encrypted or they could not be. So what you want to make sure is that any data that you're storing in etcd, you're okay with it being unencrypted unless you specify otherwise. It, in the console, looks like a base 64 encoded value, which only obscures it so much. We have our deployment tool that I mentioned in the past, Rocket Scripts, does secrets in two ways, which is, in my opinion, a sort of clever way around this, is that during build time, we don't put any secrets in the container. We store secrets in a cloud storage bucket. They can be encrypted with SOPs or anything like that. And when the image is being built and deployed, the secrets are pulled from that cloud storage bucket, unencrypted, created into a Kubernetes secret, and injected into etcd. And so those secrets are never written on the build system. They're injected into etcd at runtime, and we leave that there. You are responsible, again, for encrypting that data as it goes into etcd. But then, of course, your application has to unencrypt it, right? Does that answer your question? OK, perfect. I think HashiCorp announced today that they're doing Kubernetes native Vault or something like that. I saw that on the Twitters. So that could be cool. We have a couple customers really interested in Vault. OK, so we have deployments. Let's use those deployments. So what I'm going to do is go back to the root. Oh, not what I wanted. Go back to the root. And I'm going to clone this repo. If I grab the HTTP version, it's going to be available to me in Cloud Console. So let's go back here. I'm going to say, I probably already have it, so let me remove the old one. So I'm just going to say git clone that repo. Hopefully this is familiar to you. It's going to check out the code. So now I have it available in Kate's workshop. If I go into that directory, I have the code as we looked at it. So we were talking about redis. Let's deploy it. OK, this is where it gets cool. So you can deploy this by hand manually with kubectl. You could deploy this automatically with one of our tools like Rocket Scripts. But this is going to show you the primitive way to do it. So let's see. We have all of these configuration files. One of the things that I really love about the way that we manage resources is that we keep them as Kubernetes native YAML, which is nice. There are a lot of packages out there now that are doing DSL wrappers and templates, right? Which is fine, and it makes things easier in a certain way, but it's going to remove you from the reality of a Kubernetes resource. So I think it's important for you to understand them at their native level and be able to apply them manually before you start using any of those other fancy packages. Okay. So in this case, I'm showing you the old school method. So we have our deployments here in our services. I am in my workshop context, which means I'm in my workshop namespace. So now all I have to do to deploy these files is say kubectl apply -f, which means input a file, and the file name. Redis master deployment.yaml. Now, these file names are ReactiveOps-ish file names. These are not like Kubernetes documentation named, but we find it useful to put the resource type as kind of a suffix, just so that you can keep things separate. You could potentially, since it's YAML, you could shove all these in one file if you wanted to. We just like to keep the flavors separate. So if I say kubectl apply, it is going to now create that resource in Kubernetes. And so now if I say kubectl get deployments, it's going to show me a list of deployments that I applied. And now we see my Redis master there. So we could, just like we did with the nodes, we could say describe, which will give us a bunch of info, right? It'll tell us how many are running, how many are available, all the labels, etc. That's cool. If I wanted to get rid of that, I could just, because we're doing this now, delete deployment, Redis master, and get rid of it. It's cleaning it all up now. So now if I said, get deployments, it's going to be gone. So super flexible, super fast. And then I'm going to apply it again. And we've got it back. And so now that deployment it's the recipe, so it should have cooked a thing, right? It should have made a pod. So let's say getctl, or kubectl get pods. Cool, we have a pod, and it's running. Awesome. Now, if it were not running, it would show either there's statuses like container creating. The other one you'll see a lot if it's failing is crash back off loop or something like that. It will tell you right there what the problem is. And if I were to describe that pod, I could say describe pod and take that name. So it's, again, kubectl, the action you want to take, the type of resource, and then the resource name. Okay, it's describing that pod, which is pretty cool because this bottom part, which is just like we talked about earlier with the nodes, it's telling me all of the events that have happened with that pod. So it scheduled it, it pulled the image, it created it, and then it started it. And if you have any problems with your application running, it's going to tell you right here. It's going to tell you I couldn't pull that image, or it's crashing, or doesn't have enough resources, things like that. So that's pretty neat.